Davidson again. I'm a fisheries biologist working for Natural Resources Wales, primarily on Atlantic salmon and sea trout. And my role focuses on two areas. Firstly, the running of a long-term, now 30-year index river monitoring programme for these species on the Dee. And secondly, assessment of salmon and sea trout stocks on all principal rivers in Wales. And these areas are related in that the detailed information we collect from the Dee and a small number of other intensively monitored rivers helps inform the way salmon stocks are assessed across all rivers in England and Wales. And I'll refer to both these areas in describing how salmon are faring on the Dee. But given the title of this webinar, we can already conclude that there are significant concerns about the status of salmon on this river, and not only on this river, but across much of the Atlantic range. I'll also briefly describe some of the pressures salmon are facing and provide examples of work being undertaken to help alleviate those pressures. But to start with, I thought it might be appropriate to begin with a brief description of the salmon's life cycle. So Atlantic salmon are an anadromous species. They spawn in fresh water in winter, burying their eggs in river gravels, and most adult fish spawn only once. The eggs hatch in the spring and the young fish emerge from the gravel soon afterwards. And these juvenile fish, known as fry in their first summer and par thereafter, spend 1 to 3 years in river before emigrating to sea in the spring as smolts at an average size of around 14 centimetres. The ocean phase of the life cycle is the main growth phase. Salmon grow rapidly at sea, with most fish maturing and returning to spawn after 1 or 2 sea winters, a few fish after 3 sea winters. These older fish are collectively known as multi-sea winter salmon. The longer fish remain at sea, the larger the size attained at return, typically average sizes of 60 centimetres for a 1 sea winter salmon and 80 centimetres for an older salmon. The larger a female fish is at return, the more eggs it's likely to carry. Growth advantages offered by the marine environment mean that migrating from river to sea and back again makes evolutionary sense. Counter to this are the mortality risks associated with long distance travel, involved, namely to northerly waters around Faroes and Greenland. Assessing how well salmon are faring generally involves monitoring individual river stocks at various life stages to obtain some measure of abundance along with associated biological information. On most of our rivers, this information comes from 2 sources. Firstly, the collection in England and Wales by the Environment Agency and Natural Resources Wales of catch statistics from licensed net and rod fisheries. This provides information on numbers and size of fish caught and is used, for example, to model the total return of fish to the river. The second common source of information, again mainly collected by the Environment Agency and Natural Resources Wales, but increasingly now by the Rivers Trust, is data on the abundance and distribution of juvenile salmonids, fry and par, sampled using electrofishing methods in shallow river reaches. As well as the above on an index river or counted river like the River Dee, other methods are employed, namely in the case of the Dee, the trapping and tagging of adult fish at Chesterweir to estimate the returning stock and collect biological details by more direct methods than angling. Similarly, other temporary trapping methods are employed on the Dee to sample and tag out-migrating smolts to evaluate return rates as a measure of how well fish are surviving at sea. The next step is to apply these measures of abundance and associated information to evaluate stock performance against some benchmark or standard that represents a healthy stock. So I won't go into detail here. This figure shows the for Atlantic salmon, conservation limits are applied as a common international standard, below which ideally populations shouldn't fall. And this figure shows conservation limit and some associated reference points and their position on this curve, which relates numbers of eggs laid to numbers of smolts produced. won't go into the detail, but the main point here is that the conservation limit is a protective reference point. What we want to see, or what we want to avoid, is falling below the conservation limit, where the steep slope of the curve means that stocks are at risk of rapid decline. So what about the status of the stock on the Dee? Well, this is the kind of graphical method we use to assess how well river stocks are performing against their conservation limit. But the point here is, I won't go into detail, but the Dee in 2021 is at risk, the worst risk category, against its conservation limit. But it's not unusual. 91% of rivers in Wales and 74% in England share this risk status. The great majority of rivers. Only 5 out of the 64 principal rivers in England and Wales are classified as probably not at risk or not at risk in 2021, with just one river, the Tyne, up in the northeast there, in the not at risk category. So salmon across England and Wales are in some trouble. Since around, in only a few years in the last 30, have egg deposition levels on the Dee been at or above the conservation limit. And since around 2010, this situation's deteriorated, associated with a marked decline in numbers of one-sea winter salmon. So this graph here shows the numbers of one-sea winter salmon estimated from the trapping and tagging work on the Dee since we started in '91. So you can see the decline in numbers. So this downturn in the run of one-sea winter salmon has been countered to some extent by an increase in the return of multi-sea winter fish. But the number of salmon returning to the Dee overall has declined from a 3-year average of around 6,000 fish in the early 2000s to around 3,000 today. And this shift in sea age composition appears to be part of a long-term cycle, probably in response in ways that aren't clear to changes in the marine environment. So the red columns in this figure indicate the percentage of these one-sea winter salmon among fish sampled on the Dee back to the mid-1960s. And the remainder are multi-sea winter fish, mainly two-sea winter fish, the yellow columns. But you can see this kind of cyclical pattern in abundance. And other changes have also been apparent. For example, the mean size of both one and sea winter salmon has been declining progressively over the last 30 years. And this has implications for the number of eggs carried by female fish. And these changes in abundance and biology have not been unique to the Dee, but we've been recorded on other monitored rivers and appear to be widespread. And as such, they indicate that common factors are at play, again, probably largely linked to the marine environment. And most telling, perhaps of all, smolt return rates, that's an index of survival at sea, have fallen across the Atlantic range in recent decades, as this graph indicates. So in terms of abundance and survival, to capture the effects of these changes, NASCO of the North Atlantic Salmon Conservation Organisation provide this quite useful figure showing that since the 1980s, salmon numbers at sea before the operation of any fisheries have halved from around 8 to 4 million fish. And one consequence of this decline is that decline in sea survival is that it takes twice as many eggs to produce one returning salmon now than it did before 1990. What about the pressures then? Again, NASCO provide this helpful figure listing some of the generic pressures facing salmon in many of our catchments. Many items on this list will be relevant to the Dee, and there are examples where these pressures have or are being addressed. I'll go through a few examples. terms of over-exploitation by the fisheries, fundraising by anglers on the Dee and other external interests bought out an active D-net fishery between 2006 and 2009, saving in the immediate term around 800 to 1,000 salmon a year. And around the same time, the practice of voluntary catch and release of salmon by anglers was growing. And in 2020, bylaws were introduced requiring release of all rod-caught salmon in Wales due to the poor status of the stocks on all rivers. In terms of climate change, the impacts of climate change are already evident, and changes in the marine environment already appear to be impacting salmon at sea, as we've discussed. Inland, warmer, drier summers and more extreme weather events are likely to become more frequent, and these figures just show the kind of extremes experienced during Storm Desmond in the winter of 2015-16, which was associated with unusually high river temperatures and extreme flows in the spawning and the egg incubation period. On the Dee, the temperatures and flows exceeded records from the last 50 years. And these conditions have been linked across Wales and in England, for example, to widespread recruitment failure of young salmon, in particular young salmon in 2016. So this kind of recruitment crash was observed really across the UK and neighbouring countries. So government initiatives to reduce CO2 emissions at global scale should help to minimise the worst effects of warming and climate change. But local measures will also help, for example, tree planting for shading of rivers, and ensuring that in-river habitats are connected and of high quality so that returning fish have the best chance of survival. In terms of migration barriers, this is just an example of work at the Bala sluices on the Dee. Alleviation of artificial barriers to migration allows fish to better disperse throughout a catchment and seek the best habitats. And this example, as I said, refers to the work at the Bala sluices undertaken by Natural Resources Wales to examine through tracking methods and other techniques the migratory behaviour of salmon, smolts and adults at this structure. And the Bala sluices are integral to the flow regulation system on the Dee. Now, this study is still ongoing, but adaptive management practices have already been implemented from the findings of this project to seek to improve the conditions for fish passage, as well as create more naturalised water release patterns. So those are just a few examples. There's a number of other fisheries projects are underway across Wales to tackle many of the pressures that face salmon. These include the EU Life, the Dee River project, which started in 2020 with £6.8 million of funding to alleviate barriers to migration, restore damaged riverine habitats and improve land use practices to the benefit of salmon, lamprey and other species in the Dee Sac. And more recently, last year, a similar Rivers for Life project began in South Wales, £9 million of funding to address environmental issues on the Sac rivers, Teifi, Towie, Cleddau and Usk. Similarly, other fisheries funding packages, a sustainable fisheries programme, 177k spent in 21-22 and ongoing, fisheries habitat restoration and alternative mitigation fund, which I think entirely goes to the Rivers Trust, 2.2 million from 2022 to 24, including I think £500,000 that the Dee Trust are able to spend on this catchment. A Salmon for Tomorrow fund with another £1 million to spend on projects such as alleviating fish passage and river restoration. And of course, other significant resources are expended in protecting and improving the wider environment to benefit the ecosystem as a whole. So I guess my closing conclusion is that there's a good deal of effort and resource being directed and now and has been directed in the past at the Dee and other rivers primarily to protect and improve the quality of in-river and connected habitats, estuaries and inshore waters, where we can have the biggest influence, we as regulators and you as rivers trusts. And doing this will help ensure we provide the environments that allow young salmon and trout like these ones here the best chance of surviving to adulthood, even against the current backdrop of demanding marine conditions. So it's probably all about small gains and making sure that our in-river environments, the habitats we can influence and improve, are the best they can be to give salmon the greatest chance of protection and recovery when conditions allow. So that's it. Thank you.